Alright, in this video we're going to be looking at the MOL that you took last Friday. And what we have here, number one, I had some of the class miss this, not a ton, but there was a few people who missed this question, so I wanted to make sure that I went over it. It says the table shows the side lengths of different triangles. Which are right triangles? So if you look right here, these numbers just represent which triangle it is. So we have triangle 1, 2, 3, 4. Then our lengths are these three values going across. And a lot of you, I was happy to see that a lot of you did remember the hypotenuse is the longest length. So all we need to do is figure out which one of these is C, and then put them into our calculator and see, does it say true or false? True meaning that the statement is true, and if it's true, then it means it is a right triangle. So let's take a look. This is my hypotenuse here. So I think the best thing to do with this is if you circle the hypotenuse for each one of these lines. So we got 5, 11, and 13. 13 is the hypotenuse. 15, 17, 24. 24 is the hypotenuse. And 15, 20, and 25. 25 is the hypotenuse. So really nicely, all the hypotenuse, in other words, C, is all right here on this row. And then we can just call this, might as well go in order and say this is going to be leg A and this is going to be leg B. Remember, what we said on the area model is that the two little boxes are always equal to the big box. And we're looking at cubic units, or I'm sorry, squared units. So let's go ahead and set this up. So what we have is we have a squared plus b squared equals c squared. So we could say, okay, we got 10 squared plus 24 squared equals 26 squared. And we're going to write all of these out, and then we'll check them and see which one's false or true. So we have 5 squared plus 11 squared equals 13 squared. And then we have 15 squared plus 17 squared equals 24 squared. And we have 15 squared plus 20 squared equals 25 squared. Okay? So now we're just going to look and see these all align to these values, and we're going to see which one's true or false. And I'm going to put a T or a F right on top of it, depending on which one. And remember, when it says true, what it is, when we set up the equation, the calculator is going to look and it's going to say, well, is 10 squared plus 24 squared equal to 26 squared? And if it is, it'll say true. And if these two values on each side of the equal sign are true, it makes a true statement, in other words, and they are equal to one another, then it is a right triangle. So let's go ahead and put in the first one real quick. So what we should have done is we said, okay, 10 squared plus 24 squared is equal to 26 squared. And it says that's true. So this first triangle right here is going to be true. So triangle 1 is a right triangle because 10 squared plus 24 squared is equal to 26 squared. And for those of you who may have forgotten this and you go, well, what do you mean by that? Explain a little further. Well, let's break it up. If I do my legs just A and B and hit enter, it equals 676. And if I do 26 squared and hit enter, it equals 676. So 676 is equal to 676. That means this is a right triangle. So let's do the next one. We got 5 squared plus 11 squared is equal to 13 squared. And it says false. That means those two values are not equal. So I'm just going to write me an F on my paper. So that one's false. And the next one is 15 squared plus 17 squared is equal to 24 squared. And it says it's also false. So I'm going to put an F right there. And the last one, we have 15 squared plus 20 squared is equal to 25 squared. And it is true. So I'm going to put a T. So now that we've got that done, we can see that this one's true and this one's true. So 1 and 4 are right triangles. So now let's look at our options. 1 and 2, no, that's not true. 1 and 3, no. 1 and 4, yes. That is the correct answer. And that's all you had to do. Move this over. C is the correct answer, and that's all you had to do for problem number 1. So let's go ahead and move to problem number 2 and see what happened. On problem number 2, now there's two ways we could have done this. We could have used what we call the distance formula. which is basically just the Pythagorean theorem that's been modified. That's if we didn't want to graph it. If we just wanted to take these 2 points and plug them in. Let me clear that up. There you go. So if we just wanted to take these 2 points and plug them in, we could use the distance formula. That distance formula was you have to take the square root of x2 minus x1 squared plus y2 minus y1 squared. And remember, this is just delta x and delta y. What we're looking at, we're just trying to find the total change in x squared, and we're adding that to the total change in y squared, and then we're taking the square root of it. So that's one way. We could have did it that way. And if we were doing that right, we would have labeled these up here. We could have said, okay, well, I'm going to call this x2 and y2, and I'm going to call this x1 and y1. Now, the second way to do it, which I think is the easier way, is we could have just plotted these 2 points and made a right triangle. So if we go from origin, our first one is 4, 3. So that means we're going to go on the x-axis, right? This is our x, this is our y. We're going to go over 4, 1, 2, 3, 4, and we're going to go up 3, 1, 2, 3. The next one is we have 1, negative 1, so we're going to go over 1 and then down 1, because remember, down is negative, to the left is negative, to the right is positive, and up is positive. Now, what I will say is there were several people who missed this problem, and what I noticed was you did the Pythagorean theorem correctly, you just graphed your points wrong. And because you graphed your points wrong, it changed the values. So just be careful. If you're going to graph it, make sure that you count out those spaces and graph it correctly. There's a lot of you who stopped right here, so you only went up 3 instead of going, or sorry, up 2 instead of up 3, and that caused you to get it wrong. This point was 1, negative 1. Just going to write that on there so you can see. Now, once I've done this, right, I can go ahead and do my hypotenuse and say, well, I'm looking for C, because I'm trying to find the distance between point P and point Q. This is point P right here. I can write a P, and this is point Q down here. So let's count our units. If we go from here to here, we have 1, 2, 3. So that's 3 units. And here we have 1, 2, 3, 4. That's 4 units. Now, 3 and 4. So if I'm going to do that and I'm solving for C, right, we have a squared plus b squared equals c squared. I'll call this A and I'll call this B. And what we have is we have 4 squared plus 3 squared is equal to c squared. So that's 16 plus 9 equals c squared. That's 25 is equal to c squared. If we take the square root of it, we have c is equal to 5. Now, did you have to do it this way? Well, no. We could have just used numerical solve, right? We could have went into the calculator and said menu, algebra, numerical solve, and then we could have went ahead and plugged it in. 4 squared plus 3 squared is equal to c squared, comma c, and hit enter. And it would have showed us that the answer is 5. The other thing that some of you did, I bet, is that you recognized that this is just a 3, 4, 5 triangle. Remember, anytime we have one side 3 and one side 4, we know the hypotenuse is going to be 5, just as a rule. So the second way you could have done it is we could have looked right here at the distance formula, and let's plug these numbers in. So I got my x2, which is 4. So I got 4 minus my x1, which is 1, squared, plus my y2, which y2 is 3. And then that's going to be minus, and then my y1 is negative 1. Notice I put an extra parenthesis for that negative 1. That just keeps me from making a mistake. I like doing it that way. And now that I got that, I can just put that into my calculator. So if I put that into my calculator, right, this one we're not using numerical solve. We're just going to go ahead and put our radical, and we're going to put our parenthesis and write it just like we got it. 4 minus 1 squared plus parenthesis, and then we got 3 minus negative 1, and then we're going to square that and hit enter. And notice it also gives us 5. So that was 2 different ways that you could have done it. And like I said, the third way is just basically remembering that this is a 3, 4, 5 triangle. And if we come down to our answer, it says what is the distance between point P and Q, round to the nearest tenth, and the answer is 5. Okay, problem number 3. What we have, it says a cylinder and its dimensions are shown in the diagram. Which measurement is closest to the volume of the cylinder in cubic meters? So what we got to do is look at this and go, okay, well, what does it give us right here? And if you look right here, it's a whole line, right? And we just want half of that line. So we need to go ahead and say, well, this is the diameter, and the diameter divided by 2 gives us r, which is what we want. So I'm going to plug in that number for d, right? That's my diameter. I'm going to divide it by 2. That gives me 7. So 7 is my radius. So now I can use my formula, right? V equals big B times h. Big B is equal to pi r squared, because notice our base is a circle, and the area of a circle is pi r squared. So we do pi times r, which is 7, squared, and our h is 11. So then we can just put these together. Pi 7 squared times 11. And that's equal to, let's put that in our calculator right quick. So we have pi and 7 squared times 11, and it gives us 1693.3. And if you notice, the closest answer is D, right here. So that was the correct answer. Let's take a look at the next one. The next one says, what is the volume of a barrel that has a diameter of 1.5 feet and a height of 4 feet? Okay, well, we have a barrel. If we draw that out, I'm going to make a barrel. And it has a diameter. Notice that line goes all the way across. And I'd recommend you always draw this when working on these. And it's 1.5 feet. So I'm going to say 1.5 feet. I'm going to box that. A diameter, going to underline that. And then a height, I'm going to underline it and box 4 feet. So our height is 4 feet. So now that we got this, right, we can go ahead and work this out. Now I do know, since they gave me the diameter, I must divide it by 2, and that's going to give me my r. So my diameter of 1.5 divided by 2 is going to give me my r, and that's going to give me 0.75. So now we can use our volume formula. V is equal to big B times h. Big B is equal to pi r squared, because we have circles for our base, and that's the area of a circle is pi r squared. So pi times 0.75 squared. Our h is going to be 4 feet. So now we just need to multiply these two values together, and we'll have our answer. So we got pi 0.75 squared times 4 is equal to, and let's go ahead and put that in right quick. So if I were to put that in, and I'm going to do pi times 0.75 squared times 4, and it gives me 7.06. So 7.06. And let's see what number is closest to that. Notice that they round it to the 10th place. So the answer is G. Notice it's 7.1. If we were to round to the 10th place, right, then we'd have approximately 7.1, because since this is 6, it means we move this up. And let's go to the last problem. The last problem was, a cylinder and its dimensions are shown below. Which expression can be used to find the value of B? Notice there's that big B, right? You box your variables in square centimeters for the cylinder. Okay, well, this is easy. We got V is equal to big B times H, but we're only trying to find B. So that means we don't have to worry about H. It's not applicable. So let's take a look. Big B, we're going to use pi r squared, and thankfully they give us the radius. So we don't even have to divide it. It's not the diameter, it's the radius. We get the number we need right away. So we do pi times 12.1 squared. And then we just got to look and see, okay, which one looks like pi 12.1 squared. And notice they have it right here. And notice they put it in parentheses. And earlier in class when I showed you, I showed some of y'all that sometimes I will plug these into parentheses. But if you don't, you could still match that up and know what it is. And the answer was A.